This is part 2 of exercise 16.5 count duplicates, and we previously solved this problem in part 1. However, it's important to know how to do this problem, but with recursion. And with recursion, when you look at code, basically anything that's in a loop, so this part, can be written in a recursion method. So we'll save our original code and we'll comment this out and we'll call this normal code. And then below it, we're going to have our recursion code. And we can copy a few things down. We can copy the name of our method, and we can also copy if there's an empty list. And we can copy these variables right here. We're going to do something else with our duplicates variable. So we actually do not need int duplicates here. So this is what we have so far. And now we need a recursion statement. Instead of our while loop here, we're going to look at our loop and we're basically going to put this code in a recursion method. We're implementing our recursion, and from here, since this is an int, it's returning something. We're going to return our recursion. And in here, we look at our loop and we need the prev and the current values. So we are going to pass through prev and current. And this is it for this count duplicates method. Underneath it, we're going to have our public int recursion, and its parameters are prev and current. And these are both list nodes. So now we have this written out, we can start looking at what we need to do. We have while current does not equal null, this will happen. So we're going to say that our recursion represents our loop right here. And we're just going to look at our if statement. We can copy our if statement down here. And we're going to say if prev.data is equal to current.data. But we don't have duplicates in here, so we're going to have to delete that and find another solution for that. If this happens, we are going to add 1. We're going to return a 1. But we're also going to have our recursive method with it. So it'll go back in here and check if this is equal. We're going to pass through our prev and current. However, since like in our while loop right here, we need to increment them so it will continuously compare them until we reach the end. We need to do that here too. So above our return statement, we are going to have these. And then we are just going to pass through our prev and our current. If these do not equal each other, we can't just end our code here. We are going to have a else statement. And what this else statement is doing is saying if our prev.data does not equal current.data. And in here, we are just going to increment these as well. It's basically going to be the same code as in our if statement, so we can copy that down there, but we can note that there will be one big difference. And that's in our return statement, we're not returning a 1. Because they're not equivalent, so we don't need to add a 1 to our answer. After we do this, we can close up our method and submit it. So there is an error, and that is a null pointer exception. And this is because our recursion method doesn't have a base case. So this will basically keep running on forever and ever and ever because there is no base case to stop it. To make a base case, we can set this to an else if statement, and we need an if statement right here. And in our if statement, we're going to say if current is equal to null. So if the current value that we have is equal to null, we're just going to return a 0. And what this is doing is it's saying if eventually when our current equals null, we're returning the int 0. So if we have our else if statement and we're adding on to these, it's just going to be 1 plus 0, so nothing will happen. After we run it, we pass these tests, and this is our recursion code. Going over this in a summary, we have our initial code right here. And basically we're saying if our front is null, we're just returning 0. Because if our front is empty, then there will be nothing to match it to. Now we need to compare the values in our list. So we're going to have a list node set equal to the front of our list and current set to the next node. And then we are going to compare these in our recursion method. So we're making a recursion method and we're taking these as our parameters. In our recursion method, we're having if current is equal to null, we're going to return 0. That's our base case. We have an else if statement where it's basically our while loop from before up here, and it's saying if the previous data is equal to current data, we are just going to return a recursion plus 1. So we're adding 1 to what was our duplicate value. We're basically incrementing this by 1, and then we are going into our loop again. So if this happens again, we're going to return 2 because there's 2 matches, and if there's a third match, we're going to go through our recursion again and we're going to return 3. If they're not equal, we are going to be in our else statement, and we are still going through our list because we need to examine every value, except the only thing missing here is there is no 1 plus recursion right here. So nothing is being added if they're not equal to each other.